In this lecture, we'll be taking a look at the various landforms and landscapes that are associated with tectonic plate margins. Our discussion will take a look at the various plate boundaries that are connected to the main classes that we talked about in our last lecture. And I'll try to provide you with several geographic examples for each. There are two primary landscapes that we will be associating with plate boundaries. One has to do with the process, in this case, orogens or orogenesis, the development of mountain chains. The other will relate to island arcs and the varying segments of those landscapes. Both of these provide us with really most of the landscapes that are associated with those plate margins. Orogens are, in a sense, mountain-forming crustal uplifts. That's another thing that I'd like you to associate with that term. A good example of the landforms for things like convergence and plate subduction and continental margins associated with the western coastlines of many of our continental bodies, such as South America. This is where we see this process occurring, where we see this crustal uplift and sometimes crustal thickening. With regard to, for example, South America, we see the Nazca plate moving below the South American plate. I mentioned this in our last lecture. This is an area where we see mountain building actively occurring. The Peru-Chilean Oceanic Trench is also a landscape further west from this area of interaction. This is also characteristic of an environment where we have a plate margin, we have mountain building to the east, and then we have the development of this trench, this seafloor trench to the west. Of course, to the east is where we find the Andes. So both of these, the trench associated with the ocean environment and then the mountain environment that's associated with the continental side of things, these are both characteristics of orogens or orogenesis. And that would be another kind of characteristic to keep in mind when you're talking about continental margins and orogens that are developing along those boundaries. More often than not, you will find plate convergence, and correspondingly you will find, in this case, subduction zones associated with that, and that allows for the thickening and ultimately the uplift. More uplift than thickening. Other collision environments that we'll be looking at, sometimes where they create a weld or a suture zone, this is where you would see only thickening. You wouldn't see the uplift will come with it, but it's principally thickening as part of that process. So here we have our tectonic plate map again. Look closely at this continental margin orogenesis, or at least where I've described to you that it's occurring in the case of South America. In a strictly oceanic environment, such as the interaction between the Pacific and Indian plates, just east and south of the Papuan subcontinent, you have the development of island arcs, and as I mentioned before, and I'll develop this thought even further, these island arcs are the other kind of major landform that we associate with tectonic plate margins. Keep that in mind as you review this tectonic map. Look for the kinds of boundaries that these environments would be associated with, and just get a general feel of their geographic location. So again, in strictly oceanic environments where we have this kind of continental margin interaction, well, in this case, plate boundary interaction, but again, between oceanic plates, we see the development of these island arcs. Referred to as intraoceanic in nature, these islands are formed through a great deal of volcanic activity. So when you're looking at that Pacific Rim of Fire, you'll see a lot of this occurring in areas where we have convergent plate environments. Where we see subduction occurring in relation to these island arcs, we recognize that there is a pretty steady state expression of plate interaction. So we don't get as many drastic or abbreviated or punctuated kinds of interactions rather between the plates, but we get more of a steady state kind of systematic interaction. So again, that's the island arc environment where we find that. Take a moment to review the map. Look for areas where you have plate convergence and where you have the known development of, in this case, either island environments. You can take a look throughout the Pacific and the South Pacific, and then known areas where you have the development of, in this case, mountain chains or mountainous environments. In environments where we have the convergence of one plate on another, and it is not in some sort of steady state expression of systematic movement, it is described as being in a state of collision. So collision margins can result in a wide variety of landforms as well. Intercontinental collision origins, like the Himalayas, for example, are areas where we see some pretty significant instability in the surrounding landscape, and where we have this convergence of exposed land masses welding themselves together, creating what are referred to as these suture zones. Now, subduction is occurring in the Himalayan plateau. However, what's happening above that subduction process, actually on the top of the plates themselves, is you have two continents or even continental margins being forced together. So one is being forced up against an existing continental margin. In this case, the Indian plate brings the Indian subcontinent up against the southern border of the Eurasian plate. And this creates that amazing landscape that is probably typified by the highest benchmark in the world in terms of the Himalayan mountain range and Mount Everest itself. Take a look again at the tectonic map and focus your study on the convergent boundary that is occurring just north and east of the mid-Indian Ridge, which is, of course, the oceanic environment. That's where we find that Himalayan plateau. If you bring your eyes then down and to the right, you see that in some of the island chains associated with the Bay of Bengal, and you move across toward, in this case, the Papuan Highlands. These are all environments that are the direct result of plate convergence, this intercontinental collision orogenesis. Let's take a closer look at these island arc environments. The intra-oceanic island arcs are also very dramatic landscapes that I mentioned are often associated with these plate interactions along their borders. And there's many, many examples, again, the majority of which are being found in terms of the classic examples are being found in the Western Pacific Ocean environment. They are a little bit different from the volcanic island chains that we associate with hotspots like Hawaii. These are occurring again along those margins. And what's interesting about this too is that generally they will be associated with subduction zones. So where we have convergence in this intraoceanic kind of environment and where we have subduction of one plate, generally one of these more dense basaltic plates below another that it's interacting with. It is important to mention that there are morphological and structural changes that are associated with the land masses that surround this kind of intra-oceanic island or intra-oceanic plate interaction. And these island arcs have specific kinds of geographical zones that are pretty telltale of the interaction and some of the stresses that that environment is going through in terms of physical stress. We'll take a moment to go through some of these, starting with the forearc, and I'll describe to you each of them. And I have I think a helpful diagram to allow you to kind of subdivide this interactive environment into zones or into areas that you can understand geographically and in terms of the typical kind of landforms that develop in these locations. We'll begin with the area where the greatest degree of interaction is occurring and the greatest deal of energy is being expelled with the forearc. So in the forearc environment, and again, take a moment to kind of see where that forearc is located. The forearc basin is a pretty good geographic marker for being in the forearc. In a forearc environment, we see the formation of a trench and the corresponding outer arc ridge. Here, sheets of sediment are thrust toward the surface of the water, and fragments of oceanic crust are drawn toward the mantle. The outer arc ridge is generally a submarine feature that will develop just in front of this at the point of interaction. So some geographic examples. In the case of Barbados in the West Indies, we see, in this case, entire segments of land that are pushing above sea level. These are the outer non-volcanic island environments. The Aleutian Island Arc associated with Alaska is another very good example of this. These outer arc environments are considered by geomorphologists to be unstable. However, we don't see the active volcanic activity that is associated with these areas until we move further away from the area of interaction. In this hypothetical example, the area of subduction, then moving to the right of that. So the forearc, in a sense, and the forearc basin will abut the volcanic arc, which is our next key feature. The volcanic arc is generally the second section as we move away from that area of interaction. Now, the volcanic arc itself is composed of two segments. We have further away from the area of interaction an active volcanic arc. You can see where that's located. But then as we move back toward the initial area of interaction, we have this inactive frontal arc, again located at the forearc side of the structural event. In this case, how do we know we're there? Well, geologists generally will recognize that this section of this more volcanic, more active island arc environment is composed of older volcanic rock material than what we see in the area to the right. It is this volcanic activity that typifies the volcanic arc that has also resulted in it being called a magmatic arc environment. The third and final area in our look at these island arcs, where we have two plates interacting with one another, is the back arc. Often this region consists of a larger marginal basin that separates the intra-oceanic arc and island environment from adjacent continental kinds of constructs or structures. Often it is the case that these geographical and geological expressions include what are called remnant arcs, and you can see that all the way on the right-hand side of this image. These are made of distinct materials. There is usually some sort of one-time marine material that is part of the geology of these remnant arc environments. And they'll be the oldest of the volcanic material, one-time volcanic material, that makes up this island arc environment. So when we're looking geographically for areas where these unique landscapes develop, we can look all around the Pacific plate environment. We can look across toward the Tonga Trench and the Fijian Plate. We can take a look at the Mariana Trench and some of the islands that are associated just to the east of the Philippine environment, the Philippine Islands, and of course the Philippine Plate. We can look across in the cold northern waters of the Pacific Plate environment and look at those Aleutian Islands. Those are also very characteristic of some of what we've described or looked at thus far. And then we can come down along an area just to the south and east of the Hawaiian Islands, and we can see some of that there as well. Now let's take a look at continental margins and their landforms in relation to, in this case, specific oceanic margins and the tectonic landforms that are present there. Continental margin origins and margin islands are a little bit different. You'd think they'd be the same, but there are some pretty unique differences, and we'll look at specific geographical regions that express some of these differences. Probably the most unique quality of a continental margin mountain chain or an island that is developing along a continental edge is that the event is continental in nature. So we see a lot more of that continental plate and its physical material being expressed in these landscapes and the landforms that are part of them. Generally, we will see the overriding plate material as part of these landscapes. The eastern region of the Bay of Bengal provides a very good example for this process. It would be related to the geomorphology of the Andaman Islands, the western edge of the Andaman Sea, and the western border of Sumatra, along with the northeastern or top portion of Java. These island environments, what are almost becoming subcontinental bodies in the case of Sumatra and Java, these are areas where we see that kind of continental margin orogenesis and the connection of continental margin islands with that continental, that granitic material being part of those landscapes. We also have a visible expression in the Cascade Mountains of Oregon and Washington, but this would be much more ancient in nature. So these are also areas where we see some of that continental margin orogenesis. So that would be more on the land side of things, moving away from the marine environment, these Cascade Mountains in places like Oregon and Washington. When you look at some of the primary features or landscape features that are associated with these margin environments, whether they are mountains on the continental side or if they are large subcontinents and island chains associated with the more marine environment, really the most discernible feature is the oceanic trench that forms where the oceanic lithosphere is submerging below the closely associated continent. So always looking to the east or west or north or south of that landscape to look for some sort of trench environment. This trench is going to be adjacent to the area of interaction, and there will be a debris field composed of fragments of oceanic crush that are being pushed toward the surface of the water, or being raised or pushed up. Again, take a moment to study the area surrounding the Bay of Bengal. Look for the Andaman Islands, and feel free to draw in any online resources that give you a sense of the landscape and what that landscape looks like when you're walking through it. Now, I should also mention that as we move inland away from these volcanic arc regions, we see pretty significant intrusions of granite, and we see some very dramatic kind of vertical faces that are associated with some of the mountain chains in these regions. So if you look at the Indo-Burmese mountain ranges of Burma, modern Burma, Myanmar, we see that same kind of verticality of exposed rock, principally the bedrock of the region in places like Southeast Asia. As this process unfolds, we also see a lot of the characteristic features of significant stress. Mountains will form, they will fold. We will see some of this kind of upward thrusting of folded material, and we will see pretty complex systems of fault and of drainage associated with these upland environments. When these mountainous vertical expressions of exposed rock become pretty severe or pretty extreme, The resulting mountains are often referred to as contracted continental margin origins. So there's even a subset or a subtype of mountains that we associate with these more stressed environments. So contracted continental margin origins. Well, our last type of landscape that is, again, in this case, typified by one of the two main types of landscapes, in this case mountain ranges, is this intercontinental collision orogenesis. And in this case, when you're talking about two continents coming together, that Himalayan example is a very good resource for this. But let me give you some additional information, including some information regarding the presence of oceanic lithospheric material. So as we see these pretty dramatic landscapes of crustal thickening and crustal uplift developing, and as we start to see, in this case, the development of these pretty dramatic suture zones where we have continental bodies being welded together, there are a sequence of geological events that we can associate with the deformities in the region. So let me take you through some of the parts to these events that result in probably the most dramatic mountain chains that we have on the planet today. Initially, deformities will begin to emerge as promontories along the subduction zone begin to form. The most significant expression of this upwelling of material occurs along the continental side of collision zones. Mountains will form along this line, and they will provide the material for later sedimentism within the kind of trapped oceanic environments. Beyond this, we start to see these continental bodies converging one upon the other. We will start to see what are referred to as thrust wedges that will begin to form atop the developing mountain chains. They will become more jagged and more extreme. And then the third kind of event, the kind of final piece to this mountain building puzzle with regard to the two continents colliding, is the remnant of oceanic environments or oceanic crust that is kind of closed off and either integrated into the mountain chain itself or completely obliterated as it's being subducted below whatever is occurring in this continental margin environment. So it's very extreme, and we see a lot of that kind of seismic instability in these areas. We also see that pretty significant isostatic uplift throughout these suturing zones, where the kind of continental material on the top of these plates that are interacting begin to fuse or begin to weld together. They will begin to thicken, and we'll see this kind of uplift. And this is what creates the most dramatic and the highest elevations that we have on the face of the planet. With regard to geographical examples, areas on this map that you can look for this kind of unique process, of course, I mentioned the Himalayan Plateau region, but then you can also look at the southern Zagros Mountains of modern Iran. In the dramatic Zagros Mountains, we see both Mesozoic and early Cenozoic age sediments that are being actively folded, compressed, and thrust upward as these mountains continue to grow over time. As compression arises from this intercontinental collision, the Arabian and Eurasian plates are interacting, and that's what gives us this dramatic kind of landscape. These mountains eventually become an intraplate feature. You know, they exist further away from interacting plate environments. A very good example on our side of the pond would be the Appalachian Mountain chain of North America and the North American plate. This marks a one-time location of a convergent plate boundary, similar to what we have with our Tibetan Plateau, with our Zagros Mountain chain. So a lot of information for you to process, but again, building on these three main types of plate boundaries. These are dramatic landscapes, and there are predictable qualities to these landscapes, even though when you step back and look at them through a systematic lens, you realize that they're very complex features. And they are things that are ever changing, and there's so much about these developing landscapes that we just don't know.